So I've got a little story to tell you. I've just filled in the rest of this booklet and recorded the video, except I didn't press record. So we've now got an almost fully completed booklet and no video to go with it. So hopefully this time we are recording and I can actually just talk you through what I did for the last half an hour, but actually record it this time. So here we go. Let's pick up where we left off. I'm sure that was around here. And let's run through some surds and irrational number things. First of all then, we know how to multiply integers, whole numbers. 3 times 2 is 6, that kind of thing, okay? We know how to multiply surds, I'm thinking, okay? The square root of 5 times the square root of 5 is 5. That's a little bit of a shortcut one. But the square root of 5 times the square root of 4, for example, we can't do much with other than write the square root of 20 and leave it as a surd. The one I want to pick up on, you might be able to see these reds here. I've written here these 5 times the square root of 7, so an integer times in a surd. Not a lot I can do. A little bit like 5 times x is 5x, just 5 square roots of 7. There's also a divide rule. The square root of 8 divided by the square root of 2. If you divide 2 square roots or 2 surds, you can leave the answer as a surd and just divide the numbers. So it's the square root of 4, and I've put equals 2 there. I don't think there's too much I want to say about this page. Be careful if they write, they'll either write 2 different brackets or the same bracket squared. It means the same thing, but here you've got to write that bracket twice. And then we're using the smiley face to make sure that we multiply all 4 things out. I think this might be a useful one to actually do just quickly. You've got the difference between 5 times 5, which is 25. I've done that there. You've got then the square root of, 3 square roots of 2 multiplying 3 square roots of 2. Which I'm kind of thinking of being like 3x times 3x, which is 9x squared. Again, 3 times 3 is 9, but this time the square root of 2 times the square root of 2 is 2. Meaning I've got to multiply that 9 by 2 and get an actual integer answer, 18. Whereas these two, the nose and mouth, as you were, are both 5 times 3 square roots of 2, which are 15 square roots of 2 each. Nothing to worry about with negatives. Add them all up. I can add the 25 and the 18, that's 43. And I'm thinking of these both as kind of like being 15x, add 15x, which is 30x. But it's 15 square roots of 2, add 15 square roots of 2, which is 30 square roots of 2. My answer still has a surd in it, so if they did ask, you would write that is irrational, as is this one here, which I don't think I've said. Still got that surd, so it's irrational. Bottom one was a little bit nasty. It wanted to know a value of x that would have a rational answer, so not a surd answer. Well, if we know what 3 over 2 means, it means the square root cubed. We've done it earlier in the video. So I need something that when I take the square root of it and cube it, that I get a whole number answer. So basically anything with a square root, I guess, will give me a whole number to that. So I've written all the possible answers here. 1, 4, 9, 16, 25, and so on. All these square numbers. But I've gone with 9, and I've said, okay, the little 2, square root of 9 is 3, and then cube it, square root cubed, 3 cubed, 27, that is rational, okay? It might be worth saying, look, say I had gone for 10. The square root of 10, well, doesn't have an answer, so I'll leave it at that. But then I'd have to cube it, which is the square root of 10 times the square root of 10 times the square root of 10. Well, the first two, square root of 10 times square root of 10, would just give me 10. But then I'm left with a third one, which I can't do much with. So I've still got that surd there, if you can see that in my answer. So he would have been irrational. Don't know if that makes any sense, but let's go with it. There's that page. Take a look. Take a pause if you want. And we move on. Nothing to say on these two. I'll mention this one here. Okay. It said if p is the square root of 5, q is the square root of 13, and r is the square root of 65, simplify p, q, r. I was tempted to multiply them all together, get a pretty huge number, and then try simplifying it, breaking it up. But what's the point? It's already broken up for me. I guess that's the point. So instead of doing that, I've just thought, well, leave him a minute and leave him. The 65 I actually can break up. It is 5 times 13. Bit of luck. So it becomes the square root of 5 times the square root of 13, and then multiplied by r, but I've split that up to be 5 times 13 The 2 square roots of 5 become 5. The 2 square roots of 13 become 13. Lovely. 5 times 13 is 65, which is a rational answer. Okay, it's a little bit similar to this one here. Take a load of it. This is a little bit more difficult, I guess, because you're left with a square root of 2 at the end. But you're just breaking things down and looking for opportunities to go, oh, that's a square root times the same square root, we can make that into an integer. Or that isn't a surd, something like the square root of 36, I can change that to a number. Any opportunities to get numbers out, do it until you're left with the smallest possible surd at the end. And there is that page. Okay, next page, actually there was one I didn't do the first time round when I recorded nothing, which gives me the opportunity to do it now. Let's go with, actually take my blue pen. 5 minus 3 square root of 2. It's a bit similar to one that was done a few pages back where we had positive. This time we've got to think about the negatives, gives me more to do, which is great. Let's start with u. 5 times 5, that's 25. Now the difficult bit. U times u, forget the signs for a minute. 3 times 3 is 9. The square root of 2 times the square root of 2 is 2. So that times that is 9 times 2, which is 18. Now that I've got that, now I'll look at the signs. U were negative, a minus times a minus, that is positive. That's quite similar to what actually was a couple of pages ago if we go back. Yeah, it was positive 18 there as well. I think the difference is going to come here. Okay? Because this 5 times that, it's like 5 times 3x, I guess, right? But it's 5 times 3 square root of 2, which is 15 square root of 2. As is this, 5 times 3 square root of 2, which again is 15 square root of 2. You notice I'm leaving the signs, I'll sort that out later. Now let's have a look at them. U were positive and U were negative, so this is minus. And U were positive and U were negative, so this U were minus. Add my integers, 43. Can quite often go wrong because they're both negative, but think about it. Minus 15x, start at minus 15, think about that number line. Take away another 15, okay? And you go down to minus 30 of those. And we've still got the surd in the answer, so you are irrational. I quite like, by the way, this next type of question. I wasn't going to mention it, but I will. The square root of something to the power something, we'll just write it out in full. So this one's to the power 6, so I've written square root of 3 times the square root of 3 times the square root of 3 times the square root of 3, and so on, 6 times. But for every 2 of them, I'm multiplying them together to get 3. They become 3. They become 3. Becomes 3 times 3 times 3, which is 27. And again, if it asks, this time it is a whole number, it is rational. It does not have a surd in the answer. The product of prime factors you should be okay at. I've probably done a slightly unusual route here. My normal is to start with 2 times something here, 2 times 240, 2 times that, 2 times that, 2, and keep going with 2's. But here I've gone with 10 times 36, neither of which are prime. So I've had to break the 10 into 2 times 5, both are prime. 2 times 18 for that one. Only you are prime, keep the 18 going. 2 times 9, 2 is prime. And 9 is 3 times 3. Count by 2's, 1, 2, 3. 2 cubed, couple of 3's, 3 squared, and a 5. 5 with multiple. So it is a product, meaning multiply, of prime, 2, 3, 5 are prime, numbers in index form. There's your indices. Okay, and that's why it's called a product of prime numbers in index form. Just keep in your head that the prime numbers are 2, 3, 5, 7, and 11 in this case, okay? And they quite like that question then about something being a perfect square. Well, as long as you're multiplying things with even indices, then the answer will be a perfect square. So this one down here, 3 to the power 6 times 5 to the power 4, fine. 6 and 4, both even indices. It is a perfect square. This one, 2 to the power 5 already. 5 is an odd indice, so this is not a perfect square. Let me give you some more of these, although you should try them. I've become lazy. I haven't even bothered with methods. I've just gone straight for the answers. Again, pause the page if you want to. You should be happy with those. And then a few more here. Just to mention, HCF, highest common factor, and LCM, lowest common multiple, is getting asked more and more in the last couple of years. So be confident you know the difference between factors that go into a number and multiples that number goes into. Just to make sure you get all the factors, what I tend to do, so when I was listing my factors of 30s, I start with 1 times the number, so 1 times 30. Then I think, does 2 go into the number? Well, it does in this case, it's 2 times 15. Does 3 go into the number? Yes, 3 times 10. Does 4 go into the number? No. Does 5 go into the number? Yes, 5 times 6. Okay, then the next number after 5 is 6. That's already in my list. Job done. Move on to 75. Start with 1. 1 times 75. 2 doesn't go into it. 3 does. A little bit of a division sum if it would help you. 3 times 25. 4 doesn't. 5 does. It's 5 times 15. And then as you go through, you just quickly check. 6 doesn't. 7 doesn't. 8 doesn't. 9 doesn't. 10 doesn't. And so on. So we're kind of finished with that one. Lots of common factors. 1 is common. 3 is common. 5 is common, 15 is common, and in fact 15 is the highest common factor. Compared to lowest common multiple, I'm looking at the lowest number in both times tables. I know my 6 times table, so I've just gone with my 21 times table, which I've written there. And the lowest one that's also in the 6 times table is 42. Okay, standard form. I need to get cracking before the time runs out on my videos. I think I'm allowed 20 minutes and we're 12 minutes in. Okay, be happy with the difference between small numbers, numbers less than 1, that end up with negative power of the 10, okay, and big numbers like 45,000 here, which end up with a positive number. Make sure you get that the right way round. Also make sure the decimal point goes after the first digit. So in this case, after the 5, after the 4, after the 2. The other thing that I've written in red on this page, get this into your minds, okay? For some reason, they like to write standard form, numbers that are in standard form, they like to put them in brackets. Not all the time, but sometimes. This looks almost like you're doing a bracket times a bracket. It looks like it wants to be a double bracket that you're going to have to do kind of a smiley face. You're not, okay? It is this thing, this standard form thing times this standard form thing. And you can do the numbers and the 10 separately. So I've done 3 times 4, which is 12. And then I've done 10 to the power 5 times 10 to the power minus 3. And if you're multiplying, you add the indices. 5 add minus 3, okay? If you add a minus, you're taking away 3. So 5 take away 3 is 2. Quite easy to kind of go... Job done, finished, okay, but you'd have to spot, no, 12 isn't right. It would have to be 1.2. That decimal point needs to go in there after the first number there, okay? So I'm decreasing the size of the number, all right, from 12 to 1.2. So I'm having to increase the indice from 2 to 3 to kind of counteract it, okay? The other dodgy one on this page was the divide, okay? Dividing 4.6 by 2, not a problem, 2.3, but just like times, it means you add the indices. Divide is take away. So what ends up happening here is you get 10 to the power minus 6 divided by 10 to the power minus 4, and so it's minus 6 minus 4, which hopefully you can see there. Minus 6 minus 4, and the minus becomes plus. Minus 6 plus 4 is minus 2. Answer there. Okay. Quickly moving on. Anything I want to say? Yeah, I think what I'll pick out here, if you don't mind, is this taking away one. Okay. The best way to add or take away standard form, different to multiplying and dividing, is to take it out of standard form. All right. Work out the answer and put the answer back into standard form, which you can see I've done here. 8 times 10 to the power 3 is 8,000. Minus 2,000 is 6,000 back in. But we could have just done 8 take away 2 is 6. But we can only do it because these two tens have the same power. If they were different numbers, you'd have to go about it this way. Okay? But if they're the same indice, you can just add or take away the number. In this one here, if you read it, the question's asking you for the difference between the two numbers to take them away. Well, because they're both 10 to the power 5, the answer is going to be 10 to the, something times 10 to the power 5. So I might as well just take away 3.56 from 4.06, which I've done there, and got 0.5. Another little dodgy one though. 0.5 times 10 to the power 5 is not in standard form, okay? But this time, I'm making the number bigger by moving the decimal point to there, okay? So to counteract it, the indices become smaller. I would have to multiply 5 by less powers of 10 than 0.5 to get the same answer. That's a tricky little thing to kind of get your head around. Ask me if you don't understand it, okay? Here, different indices. Right, take them out to standard form, add them together, should have written add there, and then put it back into standard form, okay? Whereas here, same indices, 13, 13, so you can just add the numbers. 15 times 10 to the power 13, that doesn't change. However, this time, making that smaller to 1.5, counteract it, make the indice bigger, okay? Here, again, you can have a look at these. The multiplying and dividing should be easy. It's just a case of adding or taking away the indices, depending on which one you're doing. Here, adding, I take them out of standard form, pretty big numbers, okay, but because one's an 8, one's a 7, I've decided it's probably the best way to do it. Worked it out, put it back into standard form. Now, don't worry about this if this makes no sense, okay? Do it this way. But if you come to here, there is an alternative to doing this with huge amounts of zeros, okay? 5 times 10 to the power 8, add 6.8 times 10 to the power 9. I can't add them just yet because the indices are, the powers here on the 10 are different. One's an 8, one's a 9. However, if you're confident doing this, but it is quite nasty, you can try and make them the same. So what I've done is said, if I want him to become 9, I'm increasing that, the power, so I need to decrease the size of the number to 0.5. So he is the same as 0.5 times 10 to the power 9. Now, because they're both 10 to the power 9, I can just add the 0.5 to the 6.8, which is 7.3, and leave the power 9. Personally, do it this way. Take it out to standard form, add them, put it back in. I think you'll find it easier. Some estimation stuff, okay? 2 to pick up on this page. I've probably got about 2 minutes left to cover this booklet, okay? This one, first of all, if I'm estimating this, I thought I'd round that to the 1 and that to 0.5, okay? Be careful. How many times does 0.5 go into 1? The answer's 2, okay? 1 divided by 0.25, just to make sure you're happy, would be 4, because 0.25 goes into 1 4 times, and so on, okay? This guy, 47 times 235 is 11,045. So write down the value of 1,104.5 divided by 0.7. So what you need to spot is I'm actually doing that divided by that. So the answer is going to be something to do with 235. But it could be that the number has to get bigger, 2,350, 2.35, that kind of thing. Or it could be that it has to be smaller. And the way to do it possibly is to estimate what you expect the answer to be. If I round 1,104 to the nearest 1,000, I get 1,000. If I round 0.47 to the nearest tenth is 0.5. Just like here, when you divide by 0.5, you double the answer. This would be 2,000, which is that's in the thousands, whereas the answer I've written is in the hundreds. So I'm going to have to add a 0, okay, to make sure that it's the right size answer, as it were. Okay. If you have a look at this page, all right. I'm not going to do these two. I'll possibly put them at the start of the next video before I run out of time. Okay, and that is that. Thank you very much. My next video will be Booklet B. Hopefully will appear online soon. Good luck with your revision, everybody.